Welcome everybody to our next example of cross products. So in this problem we're asked to determine a vector of magnitude 10 that is perpendicular to the plane passing through the x-axis and the point P at 1, 2, 4. So let's jump into this problem and see how we can solve it. So the idea again in this problem is that we are given it looks like we're only given 2 points, but really we're kind of given 3 points. And so since we know the plane passes through the x-axis, we can choose 2 points on the x-axis. And so those 2 points we could choose as being the origin, 0, 0, 0, and we can choose the point Q being the value 1, 0, 0. And so what happens then is our vector OQ is just really our unit vector I. And likewise, if the plane also contains the point P being 1, 2, 4, then if we look at the vector from O to P, then well, that's just really the position vector of the point P, and so that's given by 1, 2, 4. Now, if we're wanting a vector that's going to be orthogonal or perpendicular to both OQ and OP, then what we need is the cross product of OQ and OP. Well, computing that cross product, we use our 3 by 3 determinant as the mnemonic. So we have for OQ just being the vector 1, 0, 0, for the vector OP being 1, 2, and 4. And so what we then have for our cross product, so our first determinant being what we get when we get rid of the first row and the first column, so 0, 0, 2, and 4. Then the negative of what we have when we get rid of the first row, second column, so that's 1, 0, 1, 4. And then finally our third determinant, what we get when we get rid of the first row and the third column, so 1, 0, 1, 2. So computing these determinants, what we have is 0 minus 0 for our first one. We have a negative 4 minus 0 for the second one. And finally, for the third one, we have 2 minus 0. And so what we have as our cross product is just 0, negative 4, and 2. So now, if we want a vector that's going to have magnitude 10, that's going to be in either this direction or the negative direction, since all we care about is the fact that it is perpendicular, the idea would be then to normalize our vector. Well, let's normalize that vector and then scale it to the magnitude which we want. So if we have our normal vector being 0, negative 4, 2, then for the length of that normal vector, we just have the square root of 0 squared plus negative 4 squared, which gives us 16, and 2 squared, which is going to give us 4. And so what we have is the square root of 20, or simplifying that, we have 2 times the square root of 5. So for our unit vector, we just divide by the length of this vector, so we have a 1 over 2 root 5 times our vector 0, negative 4, and 2, which in turn gives us a vector 0, negative 2 over root 5, and then finally 1 over root 5. Well, if we want to rationalize our denominators from that, we have a 0, and we have a negative 2 root 5 over 5, and a root 5 over 5. Well, now if we want this thing to have a magnitude of 10, well, we can scale it by either a factor of 10 or negative 10. So now to get a vector of magnitude 10, we scale by 10 and negative 10. And so what this gives us, and so what we have when we simplify plus or minus 10 times our unit vector, we have a value of 0, and then we have plus or minus 4 root 5, and then switching the signs, we have a minus or a plus of 2 root 5. And so in this case, what we have for our answers, so we just have our plus or minus 0, 4 root 5, and negative 2 root 5. And so for this one, this gives us the value of our first entry for that, and we have solved our problem. So I hope you've enjoyed this problem, and I will see you guys in the next problem. See you there.